Previously, we looked at the highlights of RIP for IPv4, referred to as RIP version 1 and RIP version 2, and then we did some configuration and looked at how it behaved. Now we want to look at RIP for IPv6. We call this version RIPng. It was developed in order to be the dynamic routing protocol in the RIP family to handle IPv6. Here I've taken basically the same information but highlighted how RIPng is different. And in hindsight, I guess I should have highlighted IPv6. But given that, RIPng is still a distance vector IGP. Its administrative distance is still 120. It still uses hop count as its metric. Where we start getting different is first the concept of classful or address classes. IPv6 doesn't have that concept, so there's no such thing as a class A address only using an 8-bit subnet mask. So what that means is we take out auto-summarization. If we don't have any classes to summarize back to, we don't have auto-summarization. We can still do manual summarization with RIPng and IPv6, but without the concept of address classes, automatic summarization doesn't happen. RIPng uses a multicast address also. Its multicast address is FF02::9. And instead of using UDP port 520 as its transport protocol, it uses port 521 as its transport protocol. And those are our major differences. And then as we start, next we'll just configure it and we'll see a couple other differences. But otherwise, you know, they're both RIP, just 4 different versions of IP. So let's go ahead and configure RIPng and IPv6. Here's the topology we're going to work with, the same topology we worked with before. The only difference is now we've configured IPv6 addresses instead of IPv4 addresses. And for this video, the configuration portion will take the longest. I did already pre-configure HQ's addresses and branch 2's addresses. I didn't configure branch 1's because sometimes, even though we work with it, we may not work with a lot. And I think, for now, getting a reminder on how to configure IPv6 addresses, even though there's only a slight difference, is a good thing. So on branch 1, we're going to go through and configure our IPv6 addresses for gig01, for loopback 0, loopback 1, and loopback 2. We'll go ahead and configure those, and then we'll configure the routing. So we're on branch 1. Let's go ahead and configure our IPv6 addresses on our interfaces. Whoop. Let's first go into our gig interface. The only difference here is instead of IP address, we do IPv6 address. I know it's not a big difference, but sometimes we just need our little reminders. So IPv6, and our address on this side is FD01:1:, and the final host is 1, and we're going to use a 64-bit mask, so /64. We'll go ahead and hit enter, and that will configure our IPv6 address on gig 0. Whoops. No, it won't. Forgot the keyword address. IPv6 address FD01 :1/64. And now we actually have an IPv6 address. I'll go ahead and just continue to do this in the loopbacks. I don't know that I need to keep guiding you, so if I don't talk through it, don't worry about it. Int LO0. Our address here is FD01. :3, I believe. Look back at my topology. /64. And then we'll do int LO1. I apologize if any of my mistakes confuse you. I try to fix them as I do them, but if any of them confuse you, please ask me questions, let me know. FD01:5 on this one. 64. and then int LO2, or loopback 2. IPv6 FD01 colon, and this one is 6. I can tell I'm not real creative. Now our addresses are configured. Let's do a show IPv6 interfaces. Alright, so here we find gig00 is an IPv6 interface. It's up and up. Notice it was automatically assigned. When you enable IPv6, a link local address is automatically assigned. We didn't configure this. It gets automatically assigned and it's local, like just like it says, local to the link. And let's go ahead and scroll down. We should see loopback 0 up and up. Same thing, link local address, and then you'll see the rest of our information down below. Our global unicast address that we configured is right there. The subnet that it's in is right here. So, and so on. We keep going. Loopback 1 is up and up. Link local again. The global unicast that we assigned it. And we should have 2 should also be in here, and it is. So, we're good. Branch 1 is good. Now let's go ahead and configure routing on branch 1. Now, first thing I want to do is, I tend to do this. Sometimes I do it on purpose. If I do it on purpose, I'll let you know. And if I don't do it on purpose, well, you'll find it. There's a couple things I think you need to see. One of them being we want to, a couple things. If we enable, we can enable the RIP process separately in global config. If we don't, and when we enable on the interface, it will automatically be enabled. However, if we don't have IPv6 routing enabled, it'll throw back an error. So let's just demonstrate it. Let's go through config T, and let's go ahead and try to configure our IPv6 RIP. So IPv6 router RIP, and we just give it a name. If you hit a question mark here, it'll just say word. And we just want to identify that process. If we wanted to use a number, we could still use a number. So if you, it would be locally significant. It doesn't matter, but if you already have an autonomous system number that you use, you could use that number. So let's say my number is 100. Okay? The name 100 is just fine. RIP does not see it as an autonomous system number. It sees it simply as a name. But it could be an easy naming convention if you're running a routing protocol that uses, such as the IGRP, along with it, that uses a autonomous system number, or whatever works for you. You could be descriptive. The main thing I wanted you to notice here is that it will give you an error. IPv6 routing is not enabled. So if we go into the interface, in order to enable routing on an interface, so if we want an interface to be part of the routing process, we have to enable it on that interface. If you enable it on the interface and it's not enabled globally, it will create that routing process. However, again, it won't do it if IPv6 routing isn't enabled. We'll get the same error. I was going to show you, but I'm not going to. So let's go ahead and enable IPv6 routing. So IPv6 unicast. I'm the worst at moving my mouse. Dash routing. And yes, I could have tab completed. Now it's enabled. Now if I up arrow and I do router RIP 100, it'll actually go. Okay, we have lots of options. We're not going to go through them all, but if we hit the question mark, you can look through them. So an example is maximum paths. Remember we said that it does equal cost load balancing. By default, it'll do equal cost load balancing over 4 different paths. If we wanted it to go over more or less paths, you would use the maximum paths command. So let's say maximum. Well, let's hit a question mark. We have 32 paths available to us. Okay. Let's go. The default's 4. Let's just go less than 4, and we'll hit 3. Okay. That wasn't really in our plan, but I just wanted you to see some stuff. We can do redistribution here. We can do things with split horizon updates and timers and distribute lists. Right now we're just looking to configure basic RIP for IPv6. So we've configured our process. Now instead of configuring networks like we did previously, we're going to go ahead and we're going to enable RIP on particular interfaces that we want it to run. Okay. So GI0/0 IPv6 RIP, and our name that we gave it. In this case, I just gave it a number. Remember, you don't have to. It's locally significant. You can name it whatever you want. I'm going to stick with 100 and enable. I should have hit end. Let's do show IPv6 route. And right now we see our directly connected routes, right? Our directly connected networks. 1, 3, 5, and 6. Okay. So we're good there. I'm just gonna advertise the one route for right now. Let's go into HQ and enable RIP there. Alright, so let's go ahead and configure RIPng or IPv6 RIP routing on HQ. First, let's enable IPv6 unicast routing. So IPv6 unicast routing. I'm going to do this one the same way as I did the last one, just to kind of keep them the same, or to make it so you remember it better. But then in the last router, I'm going to do things just a little bit differently, just to demonstrate the points that I've made in here. So we do IPv6 router RIP 100, and again locally significant, so it doesn't matter, but that's the name we're going to give it. IPv6 router RIP 100. I'm not going to change maximum paths or anything else on this one, so we're just going to leave it. Now let's go ahead and I want all my interfaces, or I want both my gig interfaces to participate in IPv6 routing, so I'm going to enable it on both of them. IPv6 RIP. Enable and GI0/2 IPv6 RIP 100 enable. Now these are all directly connected, so let's go back to branch 1 to see if we had gig 02's route advertised to branch. Does that make sense? So if we go back to our picture, I know this is just kind of an experiment in remembering routing, but these guys here are directly connected to their routers. So here, this will show up in the routing table as directly connected, and in here, this same network will show up in its routing table as directly connected. So what we did with RIP isn't what we did with RIP on gig 01 here isn't going to change the routing table here, right? But whenever we go through a router, we need routing. So this address where we enabled IPv6 here should now show up in branch 1's routing table. So we'll go ahead and look, see if it does. Show IPv6 routes. Uh-oh, we didn't. What did I not remember to do? Guess I better do some troubleshooting, huh? So I did a show run on R1 to try to figure out, to start somewhere, see what I did wrong. We see it right away. I put it on the wrong interface. It should be gig 01 that has our IPv6 addresses, so I'm going to fix that real quick, and then we'll do our show IP route again. Alright, so I fixed it real quick, and now, because it's our gig 01s that are connected to each other, and so now I have this configured correctly, in the right spot, and RIP's enabled in the right spot. So let's do a show IPv6 route now. Yay, got me a little off track for a second, but we do see our RIP route to the 2 network, FD012. I noticed that it used the link local address, which is kind of cool, just because it's the one on the link that it uses to get to it, right? We said it's local to that link, and sure enough, you'll use that. It's going to do that via HQ. It's going to go to HQ's link local address if it wants to get to FD01, FD012, which is cool. So now we have IPv6 configured for branch 1. We have it configured for HQ. Now let's go ahead and configure it on branch 2. Okay, so we're on branch 2. Let's go ahead and configure it. Our interfaces on branch 2 for IPv6. I'm going to configure the routing process while I'm enabling it on the interface for branch 2. So I'm not going to change maximum paths or anything. It's just a different way of doing it. So IPv6, we still have to enable routing, right? IPv6 routing. GI0/1. Give it a name. I'm going to give it a different name this time just to demonstrate that it's only locally significant, the name. Okay, if IPv6 was already configured or enabled on this interface, if it wasn't, we would have gotten another error down here. So let's go ahead now and see. We should see no, let's go ahead and do it on our loopback also. So let me just go ahead, let's do it on our loopback. T. So our network's pretty small, we want to make sure we see it. And in fact, that should give me a good example too. IPv6, RIP. Now we should be able to, I forgot to double check to make sure these addresses on here, but I think I did. If not, you and I will troubleshoot. Let's go back now. We should see FD01:4 network back on branch 1. So branch 1, so IPv6 route. And sure enough, I do have 4. So that's the loopback of branch 2. So you notice what I wanted you to note was that routing process, two things about it. We created it on the interface rather than creating it globally, and it still works. We gave it a different name than we did both branch 1 and HQ, and it still works. Okay. Now I'm just going to go through and let's go ahead and enable RIP on the rest of our interfaces so we can get a bigger IPv6 routing table, and then we should be done. We'll verify a couple things maybe just to kind of poke around, but that'll be about it. Loopback. Oh, we got to do our loopbacks. Now remember all I'm doing here is enabling the IPv6 RIP routing process on our interfaces. Any interface that we don't want to participate in routing, we wouldn't enable it. Okay, so let's stop here. We have another one, but we're just going to let this go. So let's go ahead and see if let's go back to branch 2 and do a show IPv6 route. What we should have learned about from branch 1 would have been the :3 network, and the :5 network. We learned about :1 because that was the other side of HQ, right? That's the connection between HQ and branch. So that's a RIP learned route. It's not directly connected. We learned about 3, which is what we just enabled. And we should have learned about 5, which is what we just enabled. And if we go down, we didn't learn about any of the other ones. So routing's only going to happen on those interfaces that we enabled it on. And since we didn't enable it on loopback 2, it's not participating in the routing process. It's not announcing out, hey, this is a route you should know about. So our routers don't know about FD01:6 network. Let's do a show IP route. Notice we have no IPv4 routing happening. So when we do a regular show IP route, it doesn't work. And let's go ahead and ping. So let's ping from branch 2 all the way over. We're going to go all the way through HQ to branch 1. We're going to go to loopback 0 on branch 1. So ping FD01:3::1. And it works. So we're using RIPng to go from branch 1 all the way over to, from branch 2 all the way over to branch 1. So we've successfully configured RIPng and IPv6. There's a couple other things. I mean, some things if you, for example, if you have a default route and you want it to propagate in, you would use the IPv6 RIP, give it a name again, default information originate. If you use just default information originate, it will propagate all of it. It'll propagate the default route along with its other RIPng routes. If you use the keyword only afterwards, it will only propagate its default route. So here we just looked at dynamic. We don't have any defaults or any static routes in here. But if we did, we'd use the command IPv6 RIP default information originate, and then if we wanted to only propagate that route, we'd use the keyword only. Alright, that's it.